I told you the progress of our robotics has been making enormous progress. And today we're announcing that Groot N1 is open sourced.
Nvidia has just made a major move in robotics, quietly dropping a new open source model called Isaac Groot N1. This foundation model is built to help robots reason, plan, and act more like humans. And it's already being tested by industry leaders like 1X Technologies and Boston Dynamics. In this video, we'll break down exactly what Groot N1 is, how it works, what kind of data it was trained on, and why it matters right now. And if you stick around till the end, we'll show you how it's already being deployed in real-world robots and what's coming next. We are well aware that AI is disrupting every industry and transforming the way we work and live. But are you really taking out time to learn these AI skills and strategies that are not just a trend, but a necessity in 2025? They will not only keep you relevant for the next decade, but also help you earn an extra $10,000 every month. I know most of you are not taking action yet, so that's why let me introduce you to Grow School's 3-hour hands-on AI training, where they teach you how to use over 25+ AI tools and learn exclusive strategies and hacks. Register now using the link in the description. Trust me, this training is a game changer for people who want to grow in their career. And here's the best part. This is normally a paid training, but it is exclusively free for the first 1,000 AI Uncovered viewers who join using the link below. Yes, for free, only for AI Uncovered viewers. People who register will also receive a free $500 bonus worth of extra resources. It covers everything from job hunting strategies and salary negotiation techniques to mastering Excel and creating content. This AI training isn't just for tech folks. Whether you're in finance, sales, marketing, HR, a student, or an entrepreneur, this training is definitely for you. Grow School has helped over 1 million people upskill across the globe, and this is your chance to join and learn from the top 1% in an AI-first world. So click the link in the description, snag your free spot, and this is your only chance to learn those skills that'll secure your future. Why Groot N1 is a big deal for robotics. To understand the significance of Groot N1, it helps to look at what's been holding robotics back. While large language models like ChatGPT and Gemini have transformed how we interact with information, robotics hasn't seen the same kind of leap, mainly because real-world motion is complex, unpredictable, and often requires thousands of training hours per task. Traditionally, most robots are programmed to perform a limited set of functions in highly controlled environments. This is where Groot N1 comes in. According to Nvidia's official announcement from GTC 2024, Groot N1 is a foundational model trained to help general-purpose humanoid robots learn skills from multimodal data, combining video, text, images, and robot motion. Unlike single-task models, foundation models are designed to generalize across a broad range of environments and activities. Nvidia says the aim behind Groot N1 is to give developers a starting point they can customize for different robot hardware, applications, and scenarios. It's trained to interpret both visual and language inputs and convert them into coordinated physical actions. The open source part is also key. This isn't a closed system that only Nvidia can build on. The model weights, datasets, training benchmarks, and simulator scenarios are being made available publicly on platforms like GitHub and Hugging Face, with documentation included. And this shift comes at a time when the robotics industry is growing fast. According to Precedence Research, the global robotics market is projected to hit $283 billion by 2032, up from $72 billion in 2022. But the demand is increasingly for robots that can handle unstructured environments, not just factory lines. That's the gap Groot N1 is trying to fill. And the way it does that is through a unique architecture that mirrors how the human brain processes information. Breaking down the Groot N1 model architecture. The architecture of Groot N1 is inspired by cognitive science, specifically the idea of dual process thinking. It separates the robot's capabilities into 2 main systems. System 1 is the fast, reactive layer. It handles real-time motor control and action execution. Think of this as muscle memory or reflexes, picking something up, adjusting grip, responding to changes in physical space without stopping to think. System 2, on the other hand, is the reasoning layer. This system processes visual inputs, understands language commands, and plans actions before handing them off to System 1 for execution. This division allows robots powered by Groot-1 to act quickly when needed, but still be capable of high-level reasoning and planning. For example, if you asked a robot to clean a desk, System 2 would interpret the command and understand the scene, while System 1 would control the hands, arms, and legs in real time to carry out the cleanup. The model has been trained using data that includes both robot action trajectories and human demonstrations, videos of people performing tasks that the model can then learn to imitate. This approach allows for greater flexibility. Instead of training a robot for a single environment or workflow, Groot-1 enables learning from demonstration. That means you can show it a task once and fine-tune it to learn that behavior in context. And importantly, this dual system setup makes it possible to separate high-level cognition from low-level motor control, which could allow the same core model to be used across different robot platforms. How Groot-1 was trained. Let's talk about the data that powers this system. Training Groot-1 wasn't just about feeding it human demonstrations. It was built on a combination of three core data types: real robot trajectories captured from robotic systems performing various tasks, human video demonstrations showing people completing actions from different angles and contexts, and synthetic data generated through simulation, primarily using Nvidia's Omniverse platform. This hybrid training method addresses one of the major limitations in robotics: the cost and time involved in collecting physical world data. By simulating thousands of scenarios in virtual environments, Groot-1 can learn how to handle situations it hasn't encountered before in the real world. Omniverse enables physically accurate simulations that can be scaled for large-scale data generation, including variations in lighting, materials, object interactions, and physical constraints. According to Nvidia's research paper published on AR Crunchif in March 2025, this training method produced a model capable of generalizing across a wide range of tasks, while still allowing for customization with a relatively small amount of additional data. Rather than requiring a full training pipeline from scratch, developers can now fine-tune Groot-1 for specific robots or environments using limited examples, something that older architectures struggled with. And this isn't theoretical. There are already early adopters putting Groot-1 to use in real-world scenarios. Real-world robots already running. Groot-1. Nvidia isn't just releasing Groot-1 into a vacuum. Several robotics companies are already experimenting with it and using it to train robots in tasks that go far beyond simple pick-and-place actions. One of the first real-world applications is happening at 1X Technologies, a Norwegian robotics company backed by OpenAI. Their NEO Gamma humanoid robot is being trained using Groot-1 to perform domestic tasks in real indoor environments. According to a March 2025 Nvidia announcement, the robot can now carry out instructions like cleaning up objects, placing them in containers, or navigating around furniture without requiring task-specific code. Neo Gamma uses Groot-1 to interpret instructions like tidy up the room and then map out a plan to execute that in real time, including grasping, object sorting, and spatial navigation. The integration with Groot-1 allows it to learn new tasks from a few demonstrations and adapt its movement across different spaces without retraining from scratch. Boston Dynamics, known for its Atlas humanoid and agility robotics, the creators of the bipedal robot Digit, are also among the early adopters testing Groot-1 internally. While these companies have not yet publicly detailed how they're integrating the model, Nvidia confirmed they are part of the testing group for Groot-related developments. This is significant because these are companies with advanced mechanical platforms now exploring ways to enhance cognition and adaptability without rebuilding their software stacks from zero. For developers, this offers a shortcut. Instead of having to develop entirely new AI systems for every robot, Groot-1 provides a transferable base model. Developers can take an existing humanoid robot, fine-tune Groot-1 on their specific data, and deploy it faster than traditional pipelines would allow. The implications go beyond tech labs. In logistics, robots powered by Groot-1 could handle variable warehouse layouts. In elder care, they could assist with daily routines without needing explicit programming for each action. In retail, these systems could respond to voice commands and adapt to different store setups with fewer hard-coded rules. This isn't a universal solution, Groot N1 doesn't eliminate the need for task-specific refinement, and it's not yet capable of completely open-ended reasoning. But it represents a step toward more general-purpose robotic systems, with increasing levels of autonomy and adaptability. What you can do with Groot N1. A major part of this release is that Groot N1 is open source. That means it's not just a demonstration model, it's a tool that researchers, engineers, and startups can actually build on. Nvidia has released the core Groot N1 model, along with curated datasets, evaluation environments, and training benchmarks. This includes integration with Isaac Lab, Nvidia's robotics framework built on Omniverse and PyTorch, which is now available on GitHub. The model itself can be downloaded and deployed for fine-tuning on specific robot hardware. The training dataset includes human and robot motion capture and synthetic environments built using high-fidelity simulations. It's also accessible via Hugging Face, a platform for hosting and sharing machine learning models. The benefit of that is clear. Developers can quickly integrate Groot N1 into their own projects without setting up complex training infrastructure from scratch. There are also starter environments and tasks that allow for benchmarking Groot N1's performance. Developers can compare how their version performs on tasks like navigation, sorting, object manipulation, or multi-step action sequences. By releasing these tools openly, Nvidia is aligning with a broader trend in AI, where models like Meta's Llama, Mistral, and others are being made public to accelerate research. It also allows universities and smaller startups to work with cutting-edge models without the barriers of proprietary systems or closed APIs. While this open access brings new opportunities, it also raises questions around safety, bias in training data, and control over real-world robotic behavior. These concerns are not unique to Groot N1, but they are part of the broader conversation as generalist models move from digital interfaces into physical machines. Nvidia's bigger vision. Groot N1 isn't a one-off release. It's the first step in a larger initiative called Project Groot, short for Generalist Robot 00's training. This project was officially introduced by Nvidia CEO Jensen Huang during the GTC 2024 keynote, where it was presented alongside a broader lineup of AI and robotics advancements. Project Groot's objective is to build a scalable robotics platform where foundational models can generalize across hardware types, learn new tasks with minimal input, and undergo training in virtual environments before deployment in the real world. The project integrates directly with Nvidia's existing robotics ecosystem, which includes Isaac Sim for realistic simulation and synthetic data generation, Isaac Lab for reinforcement learning and robot training, and Jetson Orin, the edge computing hardware that powers these models on physical robots. The goal is to establish a continuous feedback loop, train robots in simulation, test and refine them in real-world settings, collect new data, and use that data to further improve the models. This approach aligns with the broader industry shift toward embodied AI, systems that not only process or generate digital content, but also act in physical environments. Groot N1 is designed to serve as a shared cognitive foundation for such systems, enabling them to learn incrementally, adapt to new scenarios, and reason through unfamiliar environments. According to Nvidia, upcoming iterations of Groot will expand training data coverage, enhance motor control precision, and strengthen the reasoning layer to support more complex multi-step planning tasks. The pace of innovation in this field is accelerating. As more companies, research institutions, and hardware makers converge around shared foundation models, the timeline from research to deployment could continue to shrink. If you've made it this far, let us know what you think in the comment section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.